Hello, and welcome to part 2 of looking at the Nouveau drivers. This is Ants Are Everywhere, and we're exploring the world of source code. Yesterday was a bit of a false start because I didn't realize that the Nouveau repository is actually a clone of the Linux repository. So it took me a moment to figure out where the Nouveau specific code was. But we found some of it, and this file that I'm looking at is has some push routines that are used in seemingly lots of places. We were looking at this fence. Where's the fence? This NVO4 fence. I don't know yet what NVO4 is. I suspect it's either a version or NV is NVIDIA. I suspect O4 is either a hardware version or a software version of the driver. I don't know which one. And we learned that fences are for, they're basically signals that the GPU can emit to indicate that it's done with some particular part of the processing. So it's used for synchronization, but not the way that you would use like an exclusive lock or a mutex or something, a mutual exclusion lock. And I had a question when I was looking at this, which is when you call this push wait, you pass it a push, which we didn't see. So we have this struct here, this NVIF push up here, which has two functions, wait and kick. And I was trying to figure out if I could see where some implementations of those functions are. And I think that one possible way to do that is to look in Chan. So Chan is a Nouveau channel. Let's see if I can jump to it. And this is in nouveauchan.h, which seems to be in the right directory, as you would suspect, since it has Nouveau in the title. So let's see if we can find out about this. And somebody was asking on the chat if these are the drivers open sourced by Linux. The background is that NVIDIA does not release open source drivers. They release what are called binary blob drivers. And then Nouveau is an attempt to reverse engineer the NVIDIA cards to have an open source driver. As I mentioned last time, I'm mainly familiar with them from the fact that I typically have to blacklist them because they cause problems whenever I have an NVIDIA card. Okay, so a Nouveau channel, we have this double NVIF push thing. One is an underscore push and one's a pointer. I don't really know what to make of that. And then we have a device, a reference to the, whoa. Hey now. A reference to the device. And VMM, maybe some kind of video memory map. I don't know. Mem user D, I'm guessing something about memory and user space. NVIF object. NV is NVIDIA. IF, maybe interface. Then we have a run list, which is an int. A chid, which is probably like a channel ID, something ID. Child ID. The chosen one ID. We also have an inst, probably instance, instrument instance, and a token. I don't know what the token is for. It might be something like a cookie that we send on the channel. Some sort of identifier for maybe like a conversation. And then we have these NVIF objects. Is that the structure we were looking at before with the push stuff? Whoa, not this. Oh. And I think that, wait, I don't think push.c exists. It doesn't. But Emacs had it in my history anyway. Okay, so this push thing, I think that's the object. Back to the chan. No, NVIF object is different. So is it what we are? No, channel is different from object. I'm guessing NVIF object is in a different file. Yes, an object.h. I wish it would open in the other window. I haven't configured this version, this Emacs config on this VM very well. So let's open object here, and let's open Nouveau Chan on the left here. And that's how I want it to be. All right, so where are we? So we've got these three objects like VRAM, GART. I don't know what GART is. And then NV SWA, maybe software. And we have Nouveau Bow, presumably some kind of buffer. Buffer out, buffer overflow. I don't know. And we have VMA, which is probably the Video Music Awards. And the context DMA. So DMA is, let me look this up again. I was going to say it's the thing that DRM is, dynamic DMA mapping. Direct, oh, is it just direct memory access? I think it's just possibly direct memory access, although maybe it's not. Memory mapping, okay. I'm going to just assume that that's sort of what it is. And then some address, which is a UN, an unsigned 64. And that's what push is to do. This will be reworked in the near future. So you say. I don't know if I can blame. I don't think I downloaded enough of the repo to blame. No, I didn't. So I can't tell how old this to-do is, but this to-do might be ancient. And then we've got this Excel done, like I guess maybe are we done with acceleration, and then a void star fence. And then another struct, which is DMA, which has what appears to be, I guess, information about a region of memory, including max, free, current, put. I don't know what put is. And then IB base, IB max, IB free, IB put. I don't know what IB stands for, but some part of memory access, I would guess. And then we have user get high, user get user put. Whatever those are. And then we have user and blit objects. And an NVIF event called kill. And an atomic thing, which I guess indicates whether we've been killed. Like whether the channel has been killed. Okay, so that's a channel. So where do we send information? I guess maybe that's what the... The Nouveau channel has a chan, and that's what the push stuff is. And I'm guessing this is kind of like a list where this first thing is the current stuff, and then this next thing is like we're going to point to the next one or something along those lines. And I guess the way that we send information is we have the buffer and memory stuff here. So I'm guessing this is essentially where the data in the channel is going, possibly with some additional information about DMA. So that's how I'm going to read this. Do we care about the object now that we've seen this a little bit? I don't know. So objects have a parent and a client. A parent is not another object, although it may have a pointer to an object. The object also has a name and a handle, so you can reference it in O class. I don't know what an O class is. Something private, which is a hack. with triple X in front of it, and some map which has some like a pointer to what appears to be memory and a size, presumably the size of the memory that you're taking up. And where's parent? Let's find out what parent is. Just going to chase some of this around. NVIF parent has some debug stuff which will printf. An NVIF parent function. But what is this doing? It just has the two debug things. What in the world? We have a constructor which sets the parent func. Oh no, okay, hang on. We've got two things. So this is the debug f. What, I don't know what print f23 is. But we have a debug function and an error function. I'm just curious about this from a design point of view. And specifically, like, why this would be called parent. So what's going on with this parent thing from a design point of view? What is its goal? It's likely used to establish a relationship between different objects. So it's a nested structure that defines a set of function pointers. These functions are intended to provide specific operations related to the parent object. Func, this is a pointer within NVIF parent that points to an instance of NVIF parent func structure. Yeah. And then these are function, the error f and debug f are function pointer members for debugging and logging and for reporting errors. Print23 is a compiler attribute that tells the compiler that the format parameter, second argument, and variable arguments after it, starting from the third argument, should be treated like the arguments to the printf function, enabling format string checking. Okay. I guess like this, that's like compiler time format string checking. And then the NVIF object is a pointer to another structure. Where is that? Did I just miss that? Oh, okay. So here's the, okay. Yeah, I did miss that. Okay, so there's this object thing here. I guess that's like where the child object goes. Although, yeah. So it acts as an interface. Different parent objects can provide their own implementation of debug and error by assigning them blah, blah, blah. It's for logging and error handling. The NVIF object passed to debug f and error f allows the parent object to provide contextual information about the object that generated the message. Okay, all of that seems fine, but the parent naming convention strongly suggests that a hierarchical relationship between objects. This pattern is often used in drivers or frameworks where objects are organized in a tree-like structure. It might be responsible for managing or coordinating the activities of its child object. Okay, but what behavior does it have to coordinate? Other than logging, what tools can it use to coordinate children? It seems like it's just this printing stuff. Yeah, I understand about parents in general. They may have, I don't know. So it's a little bit weird, but it's possible I'm missing something. It seems like this is just about printing stuff out. I don't know why this is called the parent. I don't know why that's not called like logging context. It doesn't seem to have a reference to another object. But maybe my brain is just not working today. At any rate, so this is what an NVIF object is. And most of it's sensible. We have a client. I don't think we've seen what a client is. A client has another object and an NVIF driver and a version and a route. I'm not really sure what a route is, but let's look at the driver. So we have the header and the implementation. I guess we'll look at the header first. And the driver has a name, some init function, a fini function, presumably finished, suspend, resume, IO control, IO mem, unmap, and the init takes a name, a device, and presumably just a reference to the GPU device, a configuration, I guess, some debug stuff, and *priv. In one of the structs we just saw, priv was claimed to be a XXX hack. So I'm guessing this is maybe part of the same priv thing. Or maybe it was just a hack to give that particular struct access to priv. I don't know. And that all looks fine. I don't know what the config is going to be. We haven't seen really any with the structure of that would be. It's a car star, so really anything goes. It's kind of, as far as like configuration goes, you can imagine a world, for example, where configuration had a specific structure. By making it a car star, you're basically abdicating typing at the compiler level, which is maybe done for convenience. And let's see if there's anything more interesting in the C file. We've got some if-defs about DRMs, libs, and just driver stuff, depending on whether __ kernel is defined. Here's the init function. This looks promising. So we're going to iterate over something. I guess we'll look in the client. I guess we'll set the client driver to NVIF driver at I. And I do not know where NVIF driver came from. I don't think it's passed into the function. And then for each of these drivers, if it doesn't exist, so if it's like null, or if the name of the driver doesn't match what we passed in for the driver name, then we're going to call driver init with the name and the device and the config and the debug thingy, which is, I guess, going to do like logging or debug tracking, and the client priv. And if that fails, we are going to call this finalizer thing. And the thing that we're calling here, the client driver init, I'm guessing is different from NVIF driver init, but maybe we can look at that in a bit. And if we get all the way down here, then we can assume that either hang on. So if we get down here and return a 0, then we're going to return the call. We're going to call NVIF client constructor, passing the client the name of the device in the client, and then we're going to return. And I don't know what that does. I'm guessing it constructs a client. This thing here. So if there's no, if driver is false, then we end up down here. And we don't use driver again. And that means what? That if we pass in a null driver, then we always call this constructor. But if driver is non-null, No, sorry, the opposite. If driver is non-null, then we skip this. Right? No. I was right there first time. So if driver is null, then if of it is false. Not if. Yeah, okay. So, and then if this fails, so this is somehow checking to see if the content of driver is the same as what we passed in as the client driver name. And if that's true, then ret is set to negative EIN val. Okay. This code is kind of spooky. Look into the init of the driver instance. That seems to be the real meaning. Yeah, I will. That's a good idea. I will confess that I have barely slept the last 2 nights for no particular reason. I think I was just had too much coffee. So my brain is possibly working at slower than normal speed here. The init of the driver instance. So here, I think this is what you're talking about. I guess we have to go to client. So let's go to NVIF client, which I think we've seen, then NVIF driver, which I think maybe is what we just looked at. Then where's init? We want like references to this particular init function. Virtual call. Okay. Let's see if there's another way to do this. Okay, so how about we look for calls to this? There's a keyboard shortcut for this, but I just don't remember which key it is. Okay, so it's called in Nouveau DRM.c. Where we are passing in null, and we've got the Nouveau config, the Nouveau debug, the client name, the device, and that thing. Where's this? Okay, and what do we want? We're trying to figure out where the implementation of the driver init function is, and the last thing passed in is the client, and I think that's what we want. Here's cli. So if cli is DRM master, then we go here. Otherwise, we do some mutex locking on the master lock. And we call the client constructor. That might be an important place to look. And then we unlock. Should we go to DRM master? Subcore. Let's look at the constructor. This client constructor is going to do what? You give it a parent, which, as far as I know, no, hang on. Hang on a minute here. It's the object that has a weird parent. Is that it? So the client has an object and the object has a parent, but the parent is just a logger, except that this is a parent. This is a variable called parent, which is really a client. That's a bit confusing, but that's the way it is. And then, so the constructor takes a client, which is called parent, a name, a device, and another client, which is called client, which I'm hoping is the child or a sibling or something. Although it's parent, so I'm hoping it's a child. And we're going to set some args, setting the device to the device, and we have this struct, a no-op struct. Somehow, it abuses pointer casting. Which line are you looking at? That's quite possible. Oh, is that what you're saying? Is that are you saying like the parent implementation is really like I don't know if it's doing that. It's possible that somehow what the parent object is doing is I don't know. Let's see what goes on. We're gonna do string copy from, if I remember my C correctly, I think name goes into args.name. Although size of args.name. No, I guess it must be this way. Seems like you'd want to copy from first argument to second argument. Destination source. Yeah. Oh, wait, hang on. End copy. String and copies a specific number of characters. Okay. Yeah, so I think this is copying into args. And then we've got this NVIF object constructor, which we're checking if the parent is not equal to the client. And again, my brain is not working so well today, but this is a ternary operator, and so this is what happens if this is true, I think. And so if they're different, we pass in the parent object thing. Otherwise, we pass in null to the constructor as the first argument. And then we have some default name and some class client args, etc. And if return, then we're going to return. And then we set some stuff. So the client object dot client, we set the client. What on earth? Okay, so what is client? So client is always the thing we passed in, right? I don't think we've reassigned it. So we're gonna set we're gonna look at its object and look at the client property of that object and set it to the client itself. And we'll set the object handle to tilde0, which I think is just all ones. And then we'll set the route to NVIF IO control VO route NVIF, which is maybe just some number. It's aux00, which is just 0. And we set the client driver to its parent driver. So now they share a driver. I don't know if this is copying or if they're now pointing to the same, or if they're now the same pointer. But essentially what's going on is the client's driver is now the same as the parent's driver. And if ret is 0, which I think is probably the success condition, then we're going to set ret to we're calling NVIF client IO control, client no op, and then size of no op, and we're setting the client version. Otherwise, if we have a non-zero return value, we call it destructor on the client. And where did we get the return value? We got it from calling the object constructor here. There's nothing mysterious about this, but it kind of seems like there's something like kind of like crazy about it. I don't know if it's just me this morning, or it's just a little bit hard to like the choice of variable names and stuff. That's one way to code. Yeah, I don't know. I don't know what's going on. This may be why the Nouveau driver has bugs. I mean, it's a hard thing to do. It's a hard thing to do what they're trying to do, and so it's not surprising that it's buggy. But it's kind of like unless you already know the code and the conventions, it's a little bit hard to follow what they're trying to do. If you follow through and you know what all the variables are and you chase all the things, and you kind of assemble all of that information together, it's not hard to figure out what it is actually doing. There's no like crazy flows of the code. It's all like if this, then assign that, and all of that. That's all locally sensible, but it's just a little bit hard to figure out what the design is, I guess, reading through the code. I don't even remember what we were initially trying to do. We were trying to figure out what this initialization thing was. And so at the end of this, we have this client. But what is the client? The client is itself. Sometimes we've got this object constructor, and I don't really know where the init function comes from. It maybe comes from the parent, although is parent allowed to be null? Maybe this checks for if, well, let's just ask the AIs. So I'll say in this code, what happens if parent is null, but client is not null? Yeah, so this thing. Yeah, okay, so if parent is not the client, then this will be true. However, parent object would call this a dereference of the null pointer, which would result in a crash. Therefore, in practice, this code will crash if parent is null and client is not null. Okay, so this is, in my opinion, a bug. Does that mean it's my obligation to file a bug report? That I don't know. Maybe you can tell me. Maybe I'm missing something. I mean, there can be, I guess, it's fine to have contracts where something is not supposed to be null. It would be better if that was enforced in the code, but I don't think it is, and it seems like it's possible to make that mistake. I don't know how you would check. I don't know how good static analyzers are for checking that that's never the case. So in this case, the parent and the client, okay, it results in a crash if the parent is null and the client is not null. In that case, the parent and the client are the same pointer. In the case that they are the same pointer, the parent pointer passed to NVIF object CTOR will be null. In that case, the parent is null and the client is not null. The parent pointer passed to, yeah, whatever. If the constructor succeeds, which it wouldn't because the crash mentioned above, the code proceeds to initialize the client object. Because parent is null, parent driver would cause a crash. Okay. If any of the previous steps fail or crash, the constructor is called to clean up the client object. Wait. So you're saying the destructor is called if you dereference a null pointer? When it results in undefined behavior. Yeah. Right. If it only if it, okay. Seems like the constructor is setting the object to the client. Yeah. It is. But I don't remember what the object of the client actually is. So if we, I'm going to move you aside just for a moment. So originally I was trying to figure out what this I mean, it doesn't really matter in a sense what the initialization was. Maybe it's better instead of chasing through the code to kind of peek at some of the other stuff so that we don't go down a complete rabbit hole. But this is the NVIF interface. We have driver, which we've looked at. Disp is maybe display. Here's a disp constructor. We have an M class, whatever this stuff is. I'm assuming this is maybe like now starting to be hardware stuff or chip stuff. We'll Google this and maybe like NVO4. Was that the other one? NVIDIA Ampere. Okay, so GA102 is some particular infrastructure. I don't know what NVIDIA 04 is. There's L4. Maybe it's like the GeForce 4 series. maybe it's 2004 era NVIDIA cards. We also NV50. Okay, so these are cards, specific like cards or architectures or chips or whatever. We have a destructor. We're in the implementation file, so I don't know what the header looks like. The header is in some include directory that I'm not in right now. And the implementation looks relatively straightforward. Whatever CID is, we've got this NVIF S class getting some object from the device that displays an O class. That's some sort of CID, connection ID, class ID. And then we set the object client to be null. If CID is less than 0, which is presumably some sort of error condition, then we say that the new display is not supported. And then we do some constructor on et cetera, et cetera. Okay, and we've got some masks. We have a timer, which is copyright in 2020 by Red Hat. We have this wait test, NVIF device time wait device. And this wait is different from the push wait thing, I think. If wait reads as 0, wait times 0 is time. So I'm guessing this is maybe getting the time from possibly from the GPU clock. And we're like recording it somehow. And we're doing various tests. And this is some init. So if I'm understanding correctly, this is maybe it seems like what we're doing is like possibly the GPU has a clock, and we want to use it, but because it's like a black box device, we don't have access to it. So we're like kind of keeping track of what we think the GPU clock is with this like external timer, which is maybe maybe this is one of the areas where it would be much nicer to have access to the hardware itself if that's what's going on. We can look at what NVIF device time is, I suppose. Copyright 2014 Red Hat. Wait, where'd it go? So if there's no device user.func, then we'll initialize an empty struct and call NVIF object method device object NV device v0 time. Warn on once. And then we're going to call device user.func time. So whatever user.func is, I'm going to guess that this is calling some sort of like GPU API thing. But I don't know. So NVIF object method takes an NVIF object, a method, which is just an unsigned 32, some data, which is it could be anything. It's a void star, and a size, presumably the number of data. And we've got a struct, which are the args. It takes some IO control thingamajiggy and the method, and it has a stack, and it's got something to return. And we're going to check about this stack and see if we're out of memory. And hopefully we're not. And we're going to set the IO control version to 0 and the type to NVIF IO control v0 method and the method version, etc. And then we're going to mem copy the args to the data, or vice versa. I forget which order the direction of mem copy goes. Is that how you spell it? Mem copy. This is the CPP version. What are the chances that they change the order of the arguments? So destination on the left, source on the right. So we're copying from data into method data and the size, and then we're calling NVIF object IO control, NVIF object IO control with the objects, etc. So this to me kind of feels like an API call. So how would I verify this? I could look this up. I mean, it's IO control, so Really, what else could it be? Well, let's see if we can look up this symbol. The CC1 plus, this looks like a medical page with this plus sign. Looks like one of those scammy like medical information sites that you get from Google if you Google anything like a, you know, I have a blister or whatever. Here's some LWN net. Replace I/O control with what? With what? Interface between DRM and VKM. This is a series of cleanups that I intended on doing after posting the initial GSP RM support several months ago. When is this from? 2024. The main intention is to replace the I/O control-like interface that sits between NVKM and the Nouveau DRM driver with more direct calls to reduce the call chain complexity and overhead. Okay. So NVKM is maybe NVIDIA kernel something or other. NVIDIA kernel manager. The NVKM component serves as the core abstraction layer within the Nouveau driver, responsible for managing NVIDIA GPU hardware at the kernel level. NVKM provides a unified interface for handling various GPU architectures. It enables resource management, power control, memory handling, and command submission required for the proper functioning of NVIDIA GPUs. Okay. That is all very interesting, but it doesn't tell me about how to get custom resolution, how to implement performance metrics, display timings, and so on. Yeah, so I think this is timing information. I think we're asking the GPU for a time. I'm kind of unwinding the stack here. And this is some sort of test to figure out what the timing is going on. VMM, probably virtual memory, something or other. VMM put and VMM get. And these are presumably just reading and writing. You've got this lazy thing, case lazy. Switch type, we have address ptes. I don't know what ptes is in lazy. Okay, so this is some of the interface level stuff. Well. Am I still online? So most likely every function. I don't know if I'm still online. I think I'm still successfully recording. My power blinked off. There's a big storm. And I don't know if I'm still live. Yes, you are. Oh, great. Thank you. I was trying to check on YouTube and it wasn't clear. Okay, so most likely every function that needs GPU stuff goes through the kernel manager with a special code to describe the operation. Yeah, I think so. I think that's basically the idea. At least that's what it sounds like. Here's Nouveau, just the Nouveau folder. And we have things like ACPI. This should be power. I think I opened a bunch of these in Firefox. Did I close that Firefox or not? This I can close. Here are a bunch of the things that I opened, I think. Although this is GitLab and they don't show me very clearly what the file is. Here's fence stuff. We're going to close the fences, I think. We've got more chans. We're going to chan push. This one has mutexes. It's also got a spin lock. This might be more recent. It seems to have more stuff than the first fence we looked at. And we're going to emit, read, and sync. And we've got more constructors and whatnot. And this is more fences. I don't know why I needed to open all the fence. Here's a display.h. And it's just calling this display create. This is a VMM thing. And we've got VMA unmap, VMA map, VMA find. This is possibly a search routine for like looking inside the memory, although I don't really know. Here's more VMM stuff. VGA is possibly part of the VGA interface. Here's the header. And we just have init, finish, and last close. And we'll see if any of this is interesting. We can set decode, passing in pdev and state. P device maybe. And we call a Nouveau DRM on PCI get deriv data on the pdev. And then we get a client object, client.device.object. And we're checking if it's this, whatever Curie is, presumably named after Marie Curie, who was a chemist and not at all involved in GPUs, if I remember correctly. We're checking various chipsets. What is this? This is VGA. Okay, and then based on that, and based on the state as well, we're going to return some stuff. Like this seems to be some sort of flag. RSRC. I'm not sure what that means, but we're going to order together legacy IO, legacy memory with normal IO and normal memory if state is set. Otherwise, we're going to order together normal IO and normal memory without the legacy stuff. And then we have this Nouveau switcheroo set state. If state is equal to switcheroo on, then we do some stuff. Switch power changing, switch power on, switch power changing. So this is something about, I guess, power changing. This is reprobing, etc. And here's the VGA init. If dev is PCI, this is for PCI devices. I think PCI is what? Like a plug connector? Oh, no. Yeah, it's like the is it the motherboard connector? These things, yeah. Okay, and then, but these are obsolete, right? What is the new thing? Peripheral component interconnect. I think we still call them PCI, but some like modified version. PCI Express. I don't know if this is PCIe. Okay. So at any rate, if it's PCI, then we return. Otherwise, we call to PCI device on the device to get a pdev. I guess pdev is now a PCI device. I don't know why. So if this is not a PCI device, then presumably it's something newer, but it seems like we're trying to make it into a PCI device. So I don't know if this is like a forgetful thing where it's forgetting more advanced information or what. And we're going to call this register function. If PCI is Thunderbolt attached, then we return, don't register a Thunderbolt eGPU with VGA switcheroo. Why not? I don't know. And then we've got this like finalizer thing. PCIe. Yeah, that's right. Thank you, bot yeeter. Are you eating bots? All right. I don't know what UVMM is. Memory map, maybe UV. I don't know though. I guess I'm not. I hate bots. Okay. Yeah, they are evil. The bots. Okay, I have to go soon, so I'm going to see like what's the biggest bang for my buck here in terms of learning what's going on with the Nouveau driver. TTM is what? Text to memory. I don't know, but we've got this SGDMA bind and unbind destroy. What's SGDMA? Scatter gather DMA. Okay, so this is some DMA stuff that's maybe using scatter gather. That's maybe more advanced. I think, I don't know if like consumer regular GPUs use that. Nouveau Schedge. This is some scheduling. Again, maybe this is for, I don't know. I guess maybe regular GPUs use scheduling, but you can have uninitialized, initialized, submit success, submit failed, and run success and run failed. And we've got some args and some sync thing and a count and an out sync. I'm not really sure what they do. Something about synchronizing, I assume, and synchronizing jobs specifically. A Nouveau job has a DRM Schedge job base. Maybe that's the like base region of memory, a job state, a schedule entity, a DRM file, a Nouveau client, some exec stuff, presumably reserve usage and a fence and a boolean that's somehow used for syncing, but doesn't seem to be like atomic, and some other stuff like sync data, in sync, out sync. And this thing, if .submit returns without any error, it is guaranteed that armed submit is called somehow. I don't know how we guarantee that, but this is for synchronizing various stuff about jobs, I guess. Nouveau prime, gen prime get SG table. DRM prime pages to SG. I don't know what prime is in this context. Initialize the embedded gem object. Return a single gem reference to the caller. Okay, so this seems like it's getting more to the meat of the behavior of the GPU. And I think what we were looking at the beginning of the stream is more like more of the fundamental connection stuff. I don't know what prime is. It's going to take too long to really dig into it, given the time I have. Here's Nouveau reg. This is maybe registration stuff. We see a bunch of defines. And NV50 punk bar config base valid. What's a punk bar? I don't know what gem objects are. Do you, bot eater? Memory for gem object. General GPU gems. It's now available. Oh, look at that. It's got it. That's some looks like some sort of DVD or something. Failed to look up gem object for mapping. GPU gems. GeForce. Is this Linux as well? I think that gems is maybe a Nouveau thing as opposed to an NVIDIA thing. Gem crash course. i9-15 gem. Of course, they broke the internet. It doesn't use the open source gem in the kernel. Maybe it's some piece of hardware. Gem handles return 0. Okay, in the world of the Nouveau NVIDIA driver, what does gem refer to? Gem refers to the graphics execution manager. It's a core component of the direct rendering manager subsystem of the Linux kernel, and it plays a crucial role in managing graphics memory. Okay. So it's for allocating, managing, and sharing graphics memory buffers between the kernel and user space applications. In Nouveau, as a DRM driver, it relies on gem to handle memory operations. Okay. So some sort of interface for memory between the kernel and the GPU. What is NV50? Graphics Execution Manager. Yes. DeepSeek seems to be right. So Nouveau NV50 refers to a specific microarchitecture of NVIDIA GPUs. Okay, but it encompasses a range of the GPUs, namely the GeForce 8 series through the GeForce 300 series. And what is NV50 Punk Bar? It's important to differentiate between the technical term NV50. Okay. It thinks that it's referring to a bar. Let's grab this code. In here. In this context, it's not a physical bar, but rather a set of hardware registers within the NV50 architecture. Punk bar is an internal name used by NVIDIA and subsequently the Nouveau driver developers to refer to a specific hardware block or a subunit within the NV50 architecture. It may not be publicly documented. Cool. Draw a picture of the NV50 Punk bar scene. It's not a bad picture, but I don't know if I make it. I'll say make it more inspired by the Nouveau driver and NVIDIA's hardware decisions. And let's see what it does. This is looking much better. All right, we've got an old school computer here. Yeah, we've got punks. Everything's covered in flyers for bands. They've all got basically the same mohawk, and they're all wearing more or less the same outfit. And they're like looking at some like retro 3D display of NVIDIA's latest design. I wonder if it refers to a type of chip. It might. It might. Okay. Nouveau platform.c. This is some implementations out of the header. Nouveau platform.h. Header has basically nothing. So this is for like probing the platform, removing it from, I guess, some struct or some list or something. This is checking if device ID matches. A lot of this code is like, you're just checking if one string is matching another string. But a lot of the other code seems to be like just total insanity. Not insanity, just a little bit obscure to me. It doesn't mean it's wrong or bad. It just might mean that I don't have my C driver hat on. It's been a while since I wrote just like straight up C, and I don't always remember what's easy and what's hard to do in it and all that stuff. This is some memory map stuff, which is important. I don't know. It's got a bunch of case stuff. Like if we're in NVIF case VMM GP100, then we assign various things are 1 or 0, or the size of args.gf100, etc. So like setting sizes so that presumably the memory computations can do the right thing. I'll ignore HWMon. Nouveau exec. We saw some reference to this, I think, in the job stuff. I'm guessing this is ultimately calling like an API function of the GPU to do some execution, passing in like a shader. And I only have 10 minutes. I'm not really sure that I'm gonna. The Nouveau encoder. Nouveau DRV. In fact, I think what I'm going to do is I'm going to shut all these files. I'll just go through them, BIOS, make sure that I'm not missing anything that I would really love to see. So let's see if we can find anything about Nouveau driver bugs. I'm getting sick of regressions in the proprietary NVIDIA driver. System freezing with Nouveau drivers. Nouveau driver not working. Problems with the Nouveau driver. Just look at a couple of these. Menus and list menu are often invisible. Elements appear when hovering the cursor or twinkle. And they've got some, they've got some log stuff with a bunch of trap props, including this XXX stuff. Direct framework, blah, 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 failed with error -2. I solved this problem by doing editing the environment, changing the GSK renderer to G1. Okay, so, I mean, maybe it's not, let's try asking DeepSeek. So what is the reputation of the Nouveau open source NVIDIA driver? It's quite possible that it just works almost all the time, and that I'm always asking it to do things that it doesn't want to do. The reputation is mixed, reflecting both its strengths and its limitations. Here's a breakdown. It's open source, that's good. It's integrated for basic tasks like 2D acceleration, display management, and lightweight 3D rendering. Nouveau is generally sufficient. It works well for users who don't need high-performance graphics. The most significant criticism of Nouveau is its performance. Especially for modern NVIDIA GPUs, it underperforms compared to NVIDIA's proprietary drivers, particularly in 3D rendering and gaming. So some of that might be because there are more layers. The driver has to pass through some generalization layers of the kernel, and those layers are there to provide like a uniform API for various different graphics cards. And so it may just be some of that overhead that's leading to the performance problems, but it's also probably the case that the actual like rendering software itself, the design decisions, NVIDIA has more resources and full access to the hardware to create efficiencies. But it's also possible. I almost said probable, but that was a mistake. I'm not claiming that it's probable anyway, but it's also possible that there are things that you can do within Nouveau to make it more performant. I just don't know. I barely understand the basics of what the code is trying to do. I'm certainly not at the level of being able to notice anything about performance. Lack of reclocking support. Nouveau struggles with GPU reclocking, which means it often runs the GPU at lower clock speeds to avoid instability. This severely limits its performance. Okay, that seems like a pretty structural limitation. It has limited features. Advanced features like CUDA, etc., are either missing or poorly implemented in Nouveau. This makes it unsuitable for professional workloads. Slow development. It's slow due to limited resources. This is very common in the open source world. Like reverse engineering a GPU is very specialized work. And so if you can do that, there's only a handful among all the people who can do that well. Only a small subset of them would want to spend their time volunteering to make like NVIDIA GPUs work, when NVIDIA is a huge company that has tons of money and could make them work if they wanted to. So you kind of have to be pretty mission oriented about graphics drivers in order to volunteer, and you also have to have the time available to do so. So I think this is probably true that there are limited resources. And it may not work with all of the NVIDIA GPUs. It's not the Eldritch code. So when to use Nouveau? If you value open source software and don't need high performance graphics, if you have an older NVIDIA GPU that works well, if you're troubleshooting or prefer a driver that's integrated to the Linux kernel. When to avoid Nouveau? If you need a high performance 3D rendering, gaming, or professional GPU features. If you're using a modern NVIDIA GPU that requires reclocking or advanced functionality. Is supporting reclocking possible for an open source driver? I.e., is lack of support due to limited resources, or is there some more fundamental technical barrier? Is due to a combination of technical barrier and limited resources. Modern NVIDIA GPUs require firmware to manage power states and reclocking. NVIDIA does not provide open source firmware, and without access to these firmware documentations, they can't re-implement reclocking. There's hardware complexity. It involves precise control over the GPU's power and clock states. I'm guessing that you could try to do the reverse engineering with AI for something that's hard that AI might understand, like GPU design. That might be an interesting thing. I don't know how you'd get the iteration loop fast enough where it would be like worth your time trying to do that. You'd probably need like a very good simulator of an NVIDIA GPU, or you might need a lot of them to sort of quickly cycle through test designs and give it feedback. Draw a photo of the Nouveau developers through the ages, starting in the 1990s, 2000s, 2010s, and in 2025. I don't know if ChatGPT will. No, I'm sorry. I don't know if DeepSeek draws pictures. Yeah, right. Let's ask Gemini. Gemini might refuse, although it's drawing pictures of people now. For a while, it was refusing to draw people. Okay. These just look like arbitrary computer people. And this is the same guy, but I guess he's like advanced a decade in technology, but hasn't aged. Oh, and here's here's what they look like now. That's pretty wild that they built that room for them. All right, that's all the time I have. I'll be back next week. I don't know what I will look at, but we'll look at something. And thanks for watching. Always count the fingers. That's an important advice.